Good morning, class. I hope you are having a great day. Today I would like to start off by completing one of the problems on the worksheet that is titled Apparent Weight and Acceleration. So let's go ahead and get started with one of the apparent weight problems. A student is standing on a scale in an airplane. When the airplane is traveling horizontally, the scale reads 716 newtons. Calculate the vertical acceleration of the airplane in each of the following situations. So in situation A, the scale reads 812 newtons, and in B, the scale reads 688 newtons. So what let's do is let's just go ahead and record some information. So the force that the scale reading is 716 newtons. And that means the weight force due to gravity of the student is equal to negative 716 newtons. So if we were to draw a free body diagram, the weight force of the student, the vector points in a negative y direction. So weight force due to gravity, 716 newtons. And we do not need to write our negative symbol there because we have a vector that's pointing in a negative y direction. To place the student in equilibrium is normal force, and this is going to be the force applied by the scale. This is a positive 716 newtons because the scale is pushing up on the student 716 newtons. Now, what we need to do is calculate the mass of the student. So we have the weight force due to gravity of the student is equal to the mass, the student's mass multiplied by the acceleration due to gravity. So what I want to do is isolate the mass of the student, and I'm going to divide by the acceleration due to gravity on both sides of the equal sign. So this is going to give me the student's mass is equal to the weight force divided by the acceleration due to gravity. The weight force is a negative 716 newtons, and the acceleration due to gravity is negative 9.8 meters per second squared. So let's go ahead and take out our calculator. So I have a negative 716 divided by negative 9.8. This is going to give me 73.06. Now what I want to do is take a look at my units. So we know that a newton is a kilogram meter per second squared. This unit is in my numerator. In my denominator, I have units of meters per second squared. Remember that when we divide fractions, it's like multiplying by the inverse of the denominator. So this is going to give me kilogram meters per second squared multiplied by the inverse of the denominator. This is second squared over meter. My second squared cancels, my meters cancel, and this leaves me with units of kilograms. All right, so this is the mass of the student that is stepping on the scale in the airplane. Now, what we're going to do is calculate the apparent weight of the student. And so our base equation is the apparent weight force is equal to the net force applied to the object minus the object's weight force due to gravity. Now, apparent weight force is the force that an object experiences based on all of the forces applied to the object, giving the object an acceleration. So in certain situations, you are going to feel heavier than you truly are, and in other situations, you will feel lighter than you truly are based on the forces being applied to you. And if you remember in class, we discussed getting on an elevator, and we're on the first floor, and then we want to go to the top floor. And so the elevator will accelerate our body in a positive y direction, and we will feel heavier. In another situation, when we're on the top floor and we want to go to the bottom floor. Our acceleration will be in a negative y direction, which is the same direction as the acceleration due to gravity, and therefore we will feel lighter. And we're actually able to calculate our apparent weight force using this equation here. So in example A, when the scale reads 812 newtons, okay? Well, what I want to do is first expand this right here. And so we have apparent weight force is equal to F net, which is mass times acceleration, minus the weight force due to gravity, which is mass multiplied by the acceleration due to gravity. Now what I want to do here is factor out mass on the right hand side of the equal sign. And so what I have is apparent weight force is equal to mass times acceleration minus the acceleration due to gravity, okay? Now, what we're wanting to calculate is the acceleration of the airplane in each situation for the two different scale readings. So what I want to do is isolate this variable right here. And I'm going to do that by first dividing by mass on both sides of the equal sign. So this is going to give me apparent weight force divided by mass of the object is equal to the object's acceleration minus the acceleration due to gravity. Remember, we're isolating the object's acceleration here. And so what we're going to do is add the acceleration due to gravity on both sides of the equal sign. So this is going to give me the acceleration of the object is equal to the apparent weight force divided by the mass plus the acceleration due to gravity. So this is the equation that I am going to be using for both part A and part B. So let's take a look. When the scale reads 812 newtons, okay? So acceleration equals, so our apparent weight force, so when the scale, this is the scale reading, so I have 812, and what I want to go ahead and do is break down a unit of Newton. Remember, it's a kilogram meter per second squared. And we are going to divide that by the object's mass, which we have calculated 73.06. We have units of kilograms, plus the acceleration due to gravity, which is a negative 9.8 meters per second squared. So, right here we have 812 divided by 73.06. This is going to give me 11.114. Right here, our units of kilograms cancel. This is going to leave me with units of meters per second squared minus 9.8 meters per second squared. And so our acceleration right here for part A is 1.314 meters per second squared. Okay, so if you notice here, the apparent weight is greater than the real weight force or the actual weight force of the student. And this is because the airplane is accelerating in a positive y direction, 1.314 meters per second squared. And this acceleration is in the opposite direction of the acceleration due to gravity. So it's like us being on the elevator and accelerating up the building or in a positive y direction, and so we feel heavier. So this is the answer to part A. Now for part B, when the scale reads 688 newtons. So we can go ahead and make a prediction here. We can compare the apparent weight force supplied by the scale here, 688 newtons, compared to 716 newtons. So our apparent weight force is less than our actual weight. So we can go ahead and predict that we are accelerating in a negative y direction, okay? So let's see if our prediction is true. We're going to use our base equation right here that we solved for earlier. So acceleration is equal to the apparent weight force, and this is provided by the scale, 688 newtons. But we can break up the unit of newton as a kilogram meter per second squared. We're going to divide this by the mass, 73.06 kilograms, plus a negative 9.8 meters per second squared. So 688 divided by 73.06, this is going to give me 9.416 meters per second squared, because the kilograms are going to cancel right here, minus 9.8 meters per second squared. So the acceleration of the airplane in situation B is a negative 0.383 meters per second squared. So in situation B, the airplane is accelerating in the negative y direction. Okay? I hope this helped you out on that problem. If you have any questions, just give me a call or email me, and I'll be happy to help you out. I hope you have a great day.